Okay, picking up where we left off, looking at these fundamental principles of analytical design from Tufte, this beautiful evidence text. These comparisons, causality, multivariate analysis, integration of evidence, documentation, content counts most of all. By now, it's expected that you've read that chapter, you've looked at those items. I think it's just a fascinating view into data and analysis. Um, so we're going to be talking about quantitative data analysis. We talked a little bit in the last module recording about sampling and data collection. Um, you can tell that this book is more on the group design kind of survey side. We're going to talk a little bit about single case design work here and look at visual analysis again. But let's just start with some purposes for statistical procedures. Summarizing data and looking at what's typical and atypical in a group. Show relative standing of individuals in a group. Show relationships among variables. Show similarities and differences. Identify error in the sample. Test for significance of findings. Now, I want you to recall that significance testing is just to protect against the random fluctuating hypothesis. Basically, if you haven't taken a lot of statistics, we can have a test that just protects against that it's not a random finding. That's all statistical significance testing does. It doesn't talk about the um, it doesn't talk about the effect size. Okay, so we may make other inferences about a population. So important terminology. Some of this is review, population, and sample, and then parameters, statistics, sampling error, data. This is plural always. And then this concept of code books. This is the way that you can organize and describe your data in your quantitative analysis. Some of you may have experience with statistical software, Excel being a very, very popular one, but there's others such as SPSS is another very popular one. Minitab, SAS are other examples. R is another statistical tool set that you may have some knowledge about. I wanted to just step away from that right away, in that in special education, a lot of times we're using single case designs. I want you to come away from this data analysis section with a little bit of experience, just some exposure to the concept of visual analysis. If you can just keep this slide, I think you can figure it out, but I'm going to walk you through it. These items: level, trend, variability, percentage of overlap, immediacy, and consistency are important aspects of visual design. So what do I mean by level? What I mean is that the mean of the data series changes, right? So the level, that means the score, that average is fluctuating, right? So if we're at a low steady baseline and we see a big jump up, we saw a large level change. Okay, trend. This is the slope of the lines, or the best fit line within a phase. So when we talk about trend, we talk about accelerating, decelerating. We talk about level trend. This is pretty easy to see typically, but sometimes we can use tools in Excel to draw that trend, especially if it's very subtle. Sometimes it's helpful to see trend. Sometimes it's hard to see through the next item, variability. This is the deviation of data around that best fit line. So how close to a line do you have? How much variability do you have in the data? How much separation in the data points do you have? There are scores that we can assign to variability, but we can also see it. Okay, and sometimes we use standard deviation that's a pretty well accepted way to look at variability. Okay, percentage of overlap. This is the amount of data or the percentage from one phase to another that overlaps. It's that simple. So we look for overlap. If there's a lot of overlap in data, it may show a non-effect, right? Some of that overlap may be due to this next term, immediacy. So immediacy, this is the the magnitude of change and how quickly it happens. Does that level change happen immediately, or did it take time? And we'll look at this data exemplars and look for immediacy of effect. Consistency. This is the idea of data patterns happening across phases in single case design. So in the multiple baseline example, that's kind of the classic way to look for consistency is, did we see the same type of phenomenon across the 3 or 4 replications? But we can see this across all single case design data. So let's take a look at these items, and we'll look at a data set that I know, my dissertation data, one of the data sets I should say. So let's look at child communication, and let's snap in and look at level. So if we look at Ava, Ben, and Cassie, we look at that top example from Ava. We've got the baseline condition, and we see the data starts out at just under 2, then drops under 1, and then jumps back up to about 1.5 or so, and hovers there for 3 points. So when we're talking about level change, we see a level change between baseline and intervention. Everything's certainly below 2. The mean of that data is probably somewhere around between 1 and 1.5. That's a very conservative estimate. And then we see the data jumps to typically close to 3 for 4 of those points. So we see a level change, and those are per minute frequency scores of child communication. So we see a level change in child communication. Let's talk about trend. Let's look at Ava, that top. So in baseline, we see the trend is at first, over the first 3 points, we see a deceleration. And then it shoots back up and gets stable over the last 3 points. Overall, we can call that data stable. In the intervention phase, we're going to describe that data as accelerating. So overall, we see an upward trend in that data. The point number 4 kind of drags it down a bit, but overall, that data's trending upward. Okay, so variability. We see some variability in baseline, and we see some variability in intervention. The variability that's happening at the first part of baseline for Ava, that's really problematic. So having that flatten out over those last 3 points was really important, and a prerequisite for the change to intervention that occurred. So she needed to be demonstrating stable data before intervention could occur. So immediacy, we see an immediate level change. When we compare baseline to intervention, that effect is immediate. We see no overlapping data, and then we'll talk about consistency across patterns at the end. So let's just run through Ben and Cassie in the same way. So if we look at Ben and Cassie and we talk about level, well, we see both Ben and Cassie have very low and stable baselines. They're just hovering at basically like 1 turn per session, and then it equals out to just like a 0.1 per minute frequency score. So that being said, the level is a big jump up for each of them. with Cassie's being very large at first. That novelty effect was substantial. So we see a level change in Ben and Cassie. We see trend in baseline. We see very little trend. It's very flat. And then in Ben's data, we see an upward trend to the data. It's accelerating, or it's an upward trend rather. And then we see a downward trend to the data in Cassie. So we can talk more about why we think that is, but it's certainly clear that the pattern from a visual analysis standpoint. And given more time, I'd love to tell you more about what actually was happening there, what I think the data represents with the accelerating and decelerating trends, or the upward and downward trends. Okay, back to where we're at, variability. You see very low variability at baseline for Ben and Cassie. You see some variability in the data pattern for Ben and Cassie at intervention. I recognize we're not talking much about post-intervention here. They mostly follows the same pattern as intervention. Mostly, I should say. So immediacy, we see immediate effects for both Ben and Cassie from baseline to intervention. We see zero overlapping data. And then when we look at consistency of data patterns across similar phases, for most of the characteristics, we see that same pattern of a large level change up. And then we see one variant in that we typically have this upward trend in the data for Ava and Ben, where we see a decelerating trend with Cassie during intervention. There's no overlap, so we see that consistency of data pattern. And overall, for the purposes of the study, we see that as consistent data. Okay, so we can keep looking at that. This is now moving away from the child and looking at the data taken around the paraprofessionals who are working with the children. And we can do the same thing. Let's just pick a couple of items and look at level, immediacy, and consistency of data pattern. So we see that same level change. Here we're looking at total AAC models with that white cap, and you can see that it's hovering at about 1 or less, and then it jumps way up to 4 for Ava. For Amanda. For Brooke, it's at almost 0, and then it's up around 3 plus. Colette, it's at 0, and then anywhere from 5 and change to 3. So, and you see that interesting same decelerating pattern or downward pattern to the data. And what we found is that the turns that the teachers take and the turns that the children take are linked. So if the children's taking more turns, then the teacher's going to have typically more models. And we hope that that's vice versa, right? But it's more controlled by the child turn is what we found. Because the teachers can just model even if the child's not taking turns. Okay, and then so we see the immediacy of effect is with all three, and the consistency of data pattern across phases, across these similar phase changes, we see that consistency, right? We see the low stable baselines and then the immediate upward level change across 3 participants. Okay, so for good measure, we'll look at the time delay data, and you can see a very similar pattern. Thankfully, this study worked out so well, but it was really what we expected, and it was very interesting to see it play out. This is often the harder thing to teach and kind of coach than the modeling in my research. getting people to wait for the children to take a turn. But here you can see we were effective in teaching the paraprofessionals this skill. And you can see those nice level changes. You can see the immediacy of effect and the consistency of data patterns across similar phases. So when you're looking at single case design data, whether in the top left-hand corner you have ABAB or reversal withdrawal, single case design study, or in the top right-hand corner, the multiple baseline design, or bottom left-hand corner, alternating treatment design, or the bottom right-hand corner, changing criterion design, we can use visual analysis skills to describe those graphs. This is a very good skill set for you to have. So I hope that walkthrough was useful and you can enjoy those skills in your practice. Obviously, you can do this in clinical practice and special education all day, every day. So one of the things to just step back and look at is descriptive data is really important. Oftentimes with research, we're really looking for the data of the dependent variable, right? We're hyper focused on that, but we may need some descriptive analysis to describe the data set we have. So this could be frequency distributions. This is where we're going to tabulate the number of times each value or variable occurs. Central tendency, this is stuff that's review for you, mean, median, mode. Measures of dispersion or variability. The range, this is often a very useful score in a lot of quantitative data. Quartile deviations, variance, and then, of course, standard deviation. So, one of the items that we're talking about just at the surface level is this idea of measure of relationship or correlation coefficient. This is going to connotate the negative or positive relationship and the strength of that relationship. And so you can see this general rule of thumb for interpreting correlation coefficients. Anything that's weak, this is going to be between 0 and 0.3. Moderate relationships, this is 0.3 to 0.7, and strong relationships are 0.7 to 1.0. That's just a general rule of thumb. Each scale may differ. And so you can see there's all kinds of correlation coefficients, we call them. I'll just list off a few of these that you can get some exposure. The Pearson product moment correlation, or R, biserial correlation, point biserial correlation, I believe it's phi correlation, tetrachoric correlation, Spearman-Rowe, and then Kendall tau correlation. There are also multivariate correlations, right? So we just talked about bivariate or two variables. There can be multivariate correlations, like multiple regression is a very popular one. And when we talk about measures of relative standing, oftentimes we're talking about norm reference scores. These are often based on normal distribution. And we think about the bell curve here. And some of this is important in the tests we use in special education, and of course in the tests used in research. We may sort data into percentile ranks. We may standardize the scores using a Z-score, a T-score, or a CEEB score. But on a kind of a fundamental level, with descriptive analyses, you may just put data in a table. And so here you see a frequency distribution table, and you see the total score, and then the frequency upon which that happened, and then the percentage that represents. having data in tabular format can be really helpful for readers to really get a sense of what the data set is and what we have to work with. Visual depictions, of course, are important. Here's a histogram showing the frequency of various test scores, and you can see frequency is on that horizontal axis, and then the total score is on frequency is on the vertical axis, and total score is on the horizontal axis. And so you can see that same type of data represented there. Here you see a sample bar graph showing the frequency for females and males, and you see frequency on the left there and gender on the bottom. And we can show this descriptive data in graphic format, in tabular format. Oftentimes you'll see these scatter plots, and what's interesting is you can see relationship in a scatter plot. So you see we're looking at test scores on the y-axis and hours spent studying on the x-axis, and you can see a relationship that as there's more hours spent studying, typically that test score goes up. You can see that pattern in the data. Okay, so inferential statistics. This is different than descriptive statistics, right? We're thinking about descriptive as describe, inferential as drawing inferences about. And this is where we get into items like statistical significance. Remember, this is a good way to summarize it. How likely is it that our inference is incorrect, or that it's due to just sampling error or random error? We've kind of overdone the idea of statistical significance. I'll always remember Hui Shen teaching us this, that it's just one type of threat to validity, and it doesn't show your strength of your effects. That's where we may have an effect size, but it's we may do hypothesis testing. This is where we're going to set what's called the null hypothesis, meaning that what we don't think will happen, and then an alternative hypothesis, what could happen, and we're going to then test against that. We can have p-values versus levels of significance. We basically test our p-value. We set an accepted standard for random fluctuation. 0.05 is kind of the classic level that we set, and then we test to make sure that the data adheres to that pattern. So there are different errors that can crop up in our tests. We may think we have something that's true, and it may be a false positive, right? Or it could be a false negative. These are type 1 and type 2 errors. Again, I hesitate to go any further into this without having time. It's not a statistics course. So I hope you can take this as a bit of overview. I'm feeling a little hesitant, but one of the things to know about is the concept of power and statistical power, and then effect size. And like I said, we set that level and then test for that significance. And then what I really want to show you about is this, effect. But there's different types of inferential analyses we can do. We can look for relationships, group differences, prediction. We can look at the underlying structure of the data. Like we talked about before, you have bivariate analyses, bi meaning two variable analyses. And then we have multiple variable analyses or multivariate analyses. Some of the things that you hear in this world are multiple regression, multivariate multiple regression, structural equation modeling, or SEM. Um, okay, so some of the things you might have learned in your statistics classes are around t-tests, or an analysis of variance, ANOVAs, and then multiple variate analysis of variance, or MANOVA. And you can conduct these pretty easily in most statistical packages. It's really fun to get to run these in a little data workshop. I wish we had more time to do some of that. I think it would be really fun. But that being said, you can always take some courses in that, or do a little tutorial online. Um, so, quantitative data analysis, tests for prediction of group membership, tests for prediction um, of group membership. This is where we're looking at things like discriminant analysis, logistic regression, factor analysis. This is stuff that's not really important for our purposes here. I think this is a good point here. Avoid going overboard. Sometimes people are running all these different analyses and talking about their knowledge of statistics. I just kind of backed off that right there. I realized I should have cut that slide. My apologies. It's I want you to think about statistics as a tool, okay? And they're tools to provide evidence and support of your question, or your analyzed conclusion. And so that being said, we talked about this, and in summary, the statistical significance versus practical significance. You can have really large samples, and that can help you get to statistical significance. But does it have real practical meaning? That's what we're really looking for. And you may have a sample that may fail your statistical significance test, but there may be very large differences. And so you might have to do more research to protect against that threat. But ultimately, what we're looking for is things that make a difference. And that's this practical significance, or effect size. There's statistics in each type of research that show that. In single case design research, we're fighting over a quantitative effect size score, but basically we like to get things down to a score. And if you can take anything from this, is that we want to have all this data to answer our questions, right? And I think one of the students today made a really good point, and other students were talking on Slack about quantitative versus qualitative. We're asking questions to answer them, and so we choose the tools for data collection and data analysis that fit the types of questions we have. So I hope that's useful. I hope that this concept of that you can't replace logic, that this tough chapter helps you see some important elements of analytical design, and I hope you enjoyed that. And I hope you enjoyed this brief overview of quantitative analysis. Thank you.